Stoichiometry is a fancy word for how much, and we use stoichiometry to calculate how much of a certain reactant is required to react with a certain amount of the other reactant, or maybe how much product will be formed from a certain amount of reactant, or maybe how much reactant you need to produce a certain amount of product. So basically it's just the mathematical relationship between reactants and products. The example we have right here is the formation of sodium chloride from sodium and chlorine. And the most important part of a stoichiometry problem is the balanced chemical equation, because that's really our recipe that tells us how much sodium we need to react with how much chlorine to react or to produce a certain amount of sodium chloride. And it's the coefficients in the balanced chemical equation that give us our quantities in our recipe. So we could read this equation as 2 sodium atoms and 1 chlorine molecule makes 2 sodium chloride formula units. Okay, so 2 plus 1 makes 2. We can extrapolate that and we could say 2 dozen sodiums and 1 dozen chlorines makes 2 dozen sodium chlorides. Or 200 sodiums and 100 chlorines makes 200 sodium chlorides, right? All of those things would work. We could also, of course, count in moles, because chemists like to count in moles, and the coefficients could represent moles. We could say 2 moles of sodium and 1 mole of chlorine makes 2 moles of sodium chloride. So if you're happy to count in dozens, then all you need to do is change the word dozen to moles and say 2 dozen sodiums and 1 dozen chlorine makes 2 dozen sodium chlorides. So these coefficients are what we call stoichiometric factors. They give us the molar ratio between reactants and between products. And so the relationship between sodium and sodium chloride is a 1-to-1 molar ratio. 2 sodiums form 2 sodium chlorides. So 2 moles of sodium form 2 moles of sodium chloride. And 2 to 2 is the same as 1-to-1, right? So that's a 1-to-1 molar ratio. The relationship between sodium and chlorine is 2-to-1. 2 moles of sodium reacts with 1 mole of chlorine. And we can also say the relationship between chlorine and sodium chloride is 1-to-2. 1 mole of chlorine produces 2 moles of sodium chloride. So that's a 1-to-2 molar ratio. So here we have a problem. If we've been given 2.6 moles of chlorine, how many moles of sodium chloride will we make? So we're going to go from moles of chlorine to moles of sodium chloride. And we need to write our conversion factor on the arrow with moles of chlorine on the bottom. The conversion factor is the coefficients, okay? 1 mole of chlorine produces 2 moles of sodium chloride. So I could write it as an equivalency. But on my solution map, I'm going to write it as a fraction, and I want moles of chlorine on the bottom. So 2 moles of sodium chloride per 1 mole of chlorine. And if we've been given 2.6 moles of chlorine multiplied by 2 moles of sodium chloride per 1 mole of chlorine, moles of chlorine cancel. 2.6 times 2 is 5.2 moles of sodium chloride. So we used our recipe or our balanced chemical equation to get the relationship between chlorine and sodium chloride, and we used that as our conversion factor to convert from moles of one to moles of the other.